Hello and welcome back. I am Benjamin Williams, and today we're still within the infrastructure section within Boson NetSim. Today we're going to be doing a lab on virtual router redundancy protocol authentication number 1. So let's go ahead and get into our objectives for this lab. It says in this lab, you will configure a virtual router redundancy protocol, VRRP environment, and VRRP authentication. VRRP is a network protocol that can be used to ensure the immediate and transparent recovery from first hop failures in network edge devices by providing network redundancy for IP networks. So yes, that is all true. Okay, so let's go ahead and look at our lab topology that we're going to be working with in today's lab. It says the topology diagram below represents the net map in the simulator. The VRRP routers in this topology are layer 3 switches that will be referred to as routers throughout the lab. Layer 3 switches are capable of transmitting data at layer 2 switch speeds, but can also determine for themselves how traffic should flow at layer 3. So if we take a look at our topology, we have 4 PCs. We have PC1 and PC2. They're connected to this access layer switch, which gives them access to the network. We have PC3 and PC4. They're connected to this access layer switch, which gives them access to the network. Okay, we can see that these are layer 2 switches, which are our access layer switches, and we have our distribution switches as well. And these are layer 3 switches, as it says up here in the lab. So our layer 3 switches are capable of layer 2 information, transmitting data at layer 2, but they can also route as well. We have from the A switches, we have a connection up to each distribution layer switch. Our distribution layer switches are connected to one another by Ethernet link, and then both of our distribution layer switches connect up to router 1. So that is our topology that we're working with in this lab. Before the video started, I've read through all of the commands and also the descriptions for this lab. And I've also reviewed all of the IP address information. This is good information to have for troubleshooting purposes, as well as to verify that each interface on each device has the correct IP address scheme, as well as subnet mask, okay? So let's go ahead and get into our lab task. We're going to keep our topology up here in the top left. We're going to be doing our lab readings up here in the top right. And we're going to be doing our configuration down here at the bottom, of course. Okay, so let's get into task number 1. It says configure virtual router redundancy protocol for VLAN 2 by using plain text authentication. Okay, it says dswitch 2 should be the master VRRP router for VLAN 2 on your company's network. dswitch 1 should be the backup virtual router redundancy protocol router for VLAN 2 on your company's network. In this task, you will configure virtual router redundancy protocol group 2 on VLAN 2. dswitch 1 should take over for VRRP master role when dswitch 2 goes down. You will also configure virtual router redundancy protocol authentication to ensure that only dswitch 1 and dswitch 2 can be the master VRRP routers for for VLAN number 2. Okay. So yes, it looks like we're going to be just configuring virtual router redundancy protocol, and then after that, we're going to do interface tracking, and then after that, it looks like we're going to do authentication. So if any rogue devices are connected, they will not be able to join our virtual router redundancy protocol group by using authentication. Okay, so it says on dswitch 1, configure virtual router on dswitch 1, configure virtual router redundancy protocol group 2 to automatically prompt a virtual router redundancy protocol router election when dswitch 1 has the highest priority for VRRP group 2. So let's go to dswitch 1 first, and preemption should be enabled by default, but it's asking us to go ahead and enable preemption basically. So let's go to dswitch 1. Let's give an enable. Let's do a configure terminal. Let's go into interface VLAN number 2. All right, and let's do a VRRP group 2, and let's do preempt. Perfect. Oops, preempt. Oops, I am fat fingering everything right now. That looks good. Okay. All right, now it says on dswitch 1, configure authentication for VRRP group 2 use a plain text password of $80.0 capital L 48. So let's go ahead and do that. Let's do VRRP group 2. And we want to do a authentication. Let's do a regular plain text authentication string, and we're going to do $80.0 capital L 48. All right, hit enter there. It says on DSwitch2 VLAN 2 interface, configure a priority of 110 for VRRP group 2. So let's go over to DSwitch2 now. Let's do an enable for privilege exec, configure terminal for global config. Let's go into interface VLAN 2. All right, and let's do a VRRP group 2, and let's do a priority of 110. Hit enter there. So question number 4 is saying on DSwitch2, configure virtual router redundancy protocol group 2 to automatically prompt a virtual router redundancy protocol election when DSwitch2 has the higher priority for VRRP group 2. So like I said, with virtual router redundancy protocol, preemption is already enabled by default, but let's just go ahead and do it because the lab instructions is telling us to. So we did VRRP2 preempt, okay? All right, now it says on both DSwitch1 and DSwitch2, configure virtual router redundancy protocol group 2 to use a virtual IP address of 10.10.2.3. So once we do this, since we enabled authentication on this distribution switch and not on this one, we are going to have those syslog messages repeatedly pop up in the output. But I guess that's just a part of the lab or the troubleshooting process for this lab. So let's go ahead and do VRRP2 IP address of 10.10.2.3. All right, hit enter there. Do the same thing on DSwitch2. Let's do VRRP2 IP 10.10.2.3. All right, and we are already getting those messages saying that we have bad authentication, but let's just allow the lab to work itself out. It says on DSwitch1, display virtual router redundancy protocol information for VRRP group 2, which router appears to be the master VRRP router for VRRP group 2. All right, so let's go to DSwitch1. Let's do a do show VRRP. And as we can see, it's showing as the master router, but it shouldn't be. The only reason that it's showing as the master router is because we have authentication on this layer 3 switch, but we don't have it on DSwitch2. So as soon as we configure authentication on DSwitch2, DSwitch1 should be the backup, okay? So it says on DSwitch1 and DSwitch2, compare the virtual router redundancy protocol group 2 configuration. Based on what you have configured so far, what could be causing a problem? Well, we haven't configured authentication on DSwitch2. That is the problem. So it says correct the configuration errors you noted in the previous step. So let's go to DSwitch2 now. Let's go over here. Let's do a VRRP2 authentication text. It's $80.0 capital L 48. All right, so we should stop receiving these syslog messages now. So it says allow time for the network to converge. On both DSwitch1 and DSwitch2, display VRRP information for VRRP group 2. Which router is the master for VRRP group 2 and which is the backup for the group? So let's do a do show VRRP. And as we can see, DSwitch2 is the master because it has a higher priority of 110. And if we go to DSwitch1, we can see that it has went into the backup role. So let's do a do show VRRP. And as you can see, it is the backup for group 2 because it has a lower priority of 100, which is the default. So it says on PC1, trace route to router 1's loopback 0 interface, which has an IP address of 172.16.0.1. Is traffic from PC1 being forwarded to router 1 by DSwitch2? And it should be, so let's go ahead and load up PC1. Let's do a trace RT to 172.16.0.1. And as we can see, its first hop is 10.10.2.2. If we go down here to our IP address table, we can see that that is the IP address for the VLAN 2 interface on dswitch 2. So yes, it's going through dswitch 2 first. We just confirmed that. Okay, so let's go ahead and move on to lab task number 2. It says configure virtual router redundancy protocol group 2 to use MD5 authentication. And as we know, since we configured a plain text password, if a network analyzer was on our network, if somebody was sniffing the network with a application such as Wireshark, they will be able to see our password being sent in plain text. So we can use a authentication. We can use an authentication method as of MD5 in this example to hash our password so it's not being sent in plain text. So if somebody was on our network sniffing out the network using an application such as Wireshark, they would not be able to see our password in plain text. It would be authenticated, or what is the word I'm looking for? It would be encrypted. That's the word I was looking for, to be encrypted. Okay. So it says you have configured virtual router redundancy protocol authentication for VRRP group 2. However, the authentication string you have configured is being sent across the network as plain text. Therefore, the virtual router redundancy protocol group 2 authentication string could be intercepted and configured on a rogue VRRP device. Yes, it could, because it's being sent in plain text. It says, in this lab, you will strengthen virtual router redundancy protocol authentication by changing the VRRP group 2 to authenticate by using an MD5 hash that is generated from a plain text string. Excuse me. All right, so let's start on number 1. It says on both dswitch 1 and dswitch 2, remove plain text VRRP authentication from VRRP group 2. Okay, so let's do that on both of these layer 3 switches. Let's do VRRP 2, and let's do a no VRRP group 2 authentication. Text. Let's do $80 $0NL48, and let's go to dswitch 2 and do the same thing. Let's do VRRP 2 authentication. Text. Let's do $80 $0N capital L 48. Hit enter here. Hit enter here. All right. So both of those plain text passwords are removed. So it says on dswitch 1, configure virtual router redundancy protocol group 2 to use a MD5 authentication string of this password right here. So let's go. We're already on dswitch 1. Let's do VRRP 2 authentication MD5 text string, or I think it's key string. Sorry, key string. My $80 $0N capital L 485. All right, let's hit enter there. All right, now it's saying for the next step, it says on dswitch 1, display VRRP information for VRRP group 2. What do you notice about the VRRP master role on VRRP group 2? Well, it should be the master. But the only reason it is going to be the master is because we haven't configured the same MD5 key string on dswitch 2 yet. So if we do a do show VRRP, as you can see, it's showing as the master. But like I said, that is only because we have this key string over here and not on dswitch 2. Okay, so we're getting those bad authentication messages in our syslog output. So the next step, it says on dswitch 2, configure VRRP group 2 to use MD5 authentication with a key string of the key string that's listed there. So let's go ahead and do that. Let's do VRRP2 authentication MD5 key string of my $80 $0N capital L 485. Enter. All right, now dswitch 1, as we can see from the syslog message, it has went into the backup role. So that's what we want to see. So the last step is saying on PC1, trace route to router 1's loopback 0 interface, which has an IP address of 172.16.0.1. is traffic from PC1 being forwarded to router 1 by dswitch 2. And yes, it should be, but let's just confirm that. And as we can see, it is being forwarded by dswitch 2 based on this IP address. We just confirmed that earlier, but let's just go back down, confirm one more time. We can see that 10.10.2.2 is dswitch 2's VLAN's 2 IP address. We can confirm that right there in the table. So that looks to be the end of this lab. So let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.